This right here is the worst JavaScript function, period. It sports strange syntax, it has perplexing semantics, it is entirely indecipherable, and I wrote it. Let me walk you through my thought process. If you want to cause some real confusion, a regular function just won't do it. You need a generator function. Generator functions are templates for objects called generators. To get a generator object from a generator function, simply call the generator function like any other function. Generator functions can contain the yield keyword, which helps us to describe a sequence of sorts. If you call a generator function to create a generator object and then take that object and stick it in a for-op loop, you get back all the values on the right-hand side of each and every yield keyword in the generator function. This is one way to access the sequence defined by a generator function, but there are other, more manual ways to do the same thing by calling methods on the generator object. If you call next on a generator object, the code in the generator function starts to execute. It executes until it reaches the first yield expression in the code. Then the execution of the code in the generator function itself stops. Instead of the code of the generator function itself continuing to run, the expression on the right-hand side of the yield keyword gets evaluated, and whatever value comes out of that gets returned from the generator function, together with a flag that indicates if the sequence has reached its end or not. This bundle of properties, done and the value, describes one step in the execution of this generator function. The generator function then does nothing until we decide to continue execution by calling next again. The generator function then picks up where it has previously stopped, at the previous yield expression. It continues to run code until it reaches the next yield expression, and the same thing happens again. You get back the value on the right-hand side of yield, together with a flag that tells you if the sequence is done or not. If you keep calling next, then, at least in this case, you eventually visit all the yield expressions in the entire function body. Finally, because the generator function, like every function in JavaScript, has an implicit return undefined at its very end, the last call to next gets you value undefined and done true. Done is true because you've reached a return statement and the sequence, therefore, is terminated. I'm leaving out a ton of details. This is not intended to be a complete tutorial on generator functions. I'm just looking for enough weird syntax to cause some real confusion. But there's two more details that we need to consider for our use case, and that's two more ways to control the generator. First, there's the throw method on generator objects. This method takes an exception and throws it into the generator, where it manifests itself as an exception at precisely the point where the generator function previously left off, which is the previous yield expression. The idea behind this is that you, as the party that's controlling the generator, can reject an invalid output. If you don't agree with whatever the generator function gave to you, you create an exception to complain about the value and throw it at the source of the problem. There, it can be handled using a regular try-catch block. And then the second detail is the return method on generator objects. This, in essence, inserts a return statement into the generator function, forcing the sequence to abort. This is generator functions 101, and because this is quite a lot, it's already plenty confusing for our goal of writing the worst function ever. But this is not enough. We can do way worse. Normal functions can be written like normal functions, but you could also use the function constructor to more or less eval your way to a new function. This is bad for many reasons. I mean, this function executes in the global scope and it's essentially eval, meaning it's slow and potentially very unsafe. And also, it looks quite strange, which is good for our use case. Now, can we do the same for generator functions? Yes, we can, but it's not quite easy. The ECMAScript specification does define a generator function constructor object, but this object isn't readily available. There's no global variable pointing to the generator function constructor, where the regular function constructor is exposed and we can use it no problem. But the generator function constructor is hidden. But this doesn't mean that we can't get to it. Remember that all objects in JavaScript have a property called constructor, and this property points back to the constructor that was used to construct the object in question. The neat thing about this is that this even works for objects that were created by means other than invoking the constructor function. The array literal in this example creates an array without us invoking the array constructor, but the array itself knows that if it had been constructed using a constructor, this constructor would have been the array constructor. And so, on this array in this example here, constructor points to the array constructor even though we didn't use this constructor explicitly. And this works for every object in JavaScript. For arrays, for regular objects, and, of course, even for generator function objects. So we can access the generator function constructor. All we need is a temporary generator function that we then only use to poke at its constructor property. And as you might expect, this now works just like the regular function constructor. Pass in strings for the arguments and the function body, and bam, you have a generator function object created from strings. Now this looks pretty confusing already, but we can do even worse. A generator itself is lazy. New values are only generated when the generator is prompted to do so. And this means that it's pretty easy to create a generator that represents an infinite series of values. All we need is an infinite loop. Now, infinite sequences by themselves are already a non-trivial concept to wrap your head around, but in this case, this is even actively harmful depending on the use case. Remember that generators are iterable objects, so you might be tempted to just take a generator and throw it into a for-off loop. This will work just fine, except in cases where the generator is infinite. You can still pass it to the loop, but it will crash your JavaScript runtime in short order. Our list of numbers knows no limits, but your computer hardware most certainly does. Now this generator function doesn't just look confusing, it also behaves in confusing ways and might very well crash your entire program. That's great, but there's one weakness to this particular technique. Remember that whoever's controlling the generator can force a termination of the generator by using the return method. Remember, this inserts a return statement into the generator function, causing the sequence to abort early. Or does it? Well, it depends on the generator function itself. The generator function is just JavaScript. We can write whatever code we want in there. And if we want to stop the user of our generator from stopping the sequence, we can subvert their calls to return quite easily by wrapping our entire code in a try finally block. You think the sequence is over? Think again. But this isn't quite perfect. Whoever's using the generator can simply call return again, and by doing so, escape from our finally block. To stop this from happening, we need to level up our understanding of weird generator features one final time. Suppose we have two generator functions, a and b in this example here, and we want a to output values generated by the use of b. Using straight yield won't work in this case. Generators are just regular JavaScript objects, and generators will happily yield generators as objects whenever prompted to do so. If we instead want to unwrap the generators of type B in our generator A, we have to use yield star. This delegates the generator commands sent to A to the generator B until the generator B is exhausted or terminated by some other means. We're not yielding the generator object, we are yielding the generator object's contents. If you have used flapmap with arrays or observables before, same principle. If we take yield star, we can defeat repeated attempts at aborting our generator function using the power of recursion. Isn't this awful? This isn't just an infinite sequence. It's an infinite sequence that you can't stop. And if you try to stop the infinite sequence, every attempt will create a new generator object, taking up ever more memory. This is quite horrible, but doesn't mix perfectly with all the stuff that we've discussed before. To properly recurse, we need to reference the generator function inside the generator function itself. And this works quite easily with regular generator function declarations like we have here. The function has a name, we use the name, everything works. But what we are trying to create using the generator function constructor is essentially an anonymous generator function which doesn't have a name. And if we don't have a name to refer to the generator function, how can we implement recursion? The answer to this can be found in the dustbin of legacy JavaScript features. If you, as a person who's already familiar with the concept of walking upright, want to create a variadic function, you of course use REST parameters. ... rest, you know the drill. But this syntax is somewhat new, and back in the day, we did variadic functions somewhat differently. Most types of functions in JavaScript support the arguments object. This is a magic variable that's available inside functions when they are called, and the object points to the arguments that were passed to the function, among other things. It is more or less an ancient way of doing ... rest, but it has more in store than just the arguments. It also carries a property called callee, and this property points back to the function that this arguments object belongs to. This feature is meant to solve precisely our problem. If we have an anonymous function and we want to recurse inside this anonymous function, then arguments callee helps us do just that. We don't have a name to use? Well, pivot to arguments.callee and we're good. This is how it works. Or at least this is how we did it back in the Stone Age. At some point, JavaScript got support for named function expressions. This is function expressions, like the ones you would pass to setTimeout, that can have a name. Now that callbacks can have names and we can refer to callbacks inside themselves by their name, there's no more need for arguments.callee. Since this feature was no longer needed and magic objects with strange properties pointing back to random functions are generally frowned upon, this feature was deprecated and it was made illegal to use in strict mode. And this is quite the problem for us, because non-strict mode code becomes increasingly rare. For example, every class and every module is in strict mode by default, with no way to get back to non-strict mode. And because we, of course, want our worst function of all time to keep working in strict mode, this looks like quite a big problem, but it actually isn't. Remember how functions that were created using the function constructor live in the global scope? Yeah, they are also not subject to local strict mode settings. This particular combination of circumstances allows our generator functions to keep working, even in strict mode, and even with the use of arguments.callee. This unlocks infinite recursion and an uninterruptible sequence of ever-increasing numbers. And there you have it, the worst JavaScript function in the entire world. To recap, our worst function is a generator function. We build it to yield an endless sequence of numbers. We make sure that the sequence can't be terminated via yield star and recursion. This generator function will be anonymous, which is where arguments.callee comes in. This would be illegal in strict mode, but since the function body is just a string that we pass to the generator function constructor, this code runs outside the local strict mode and works as expected. Whatever you do to this generator function, you will always get a new number. You cannot make the generator return and you cannot stop it with exceptions. New numbers will be generated until morale improves. Add a tiny bit of obfuscation to spice things up, and there we have the final shape of the worst JavaScript function in the entire world. Thank you for watching. See you next time.